Plastic Ingenuity. Won't be a commercial, I promise. We're one of the leading custom thermoformers in North America with 7 strategic locations across the continent. Our engineering center and corporate headquarters is based in Cross Plains, Wisconsin, just outside of Madison. We are an engineering-driven, privately owned company with a strong track record of organic growth and healthy balance sheet. We make our thermoform packaging out of a variety of polymers, PET, polypropylene, PLA, everything in between. My presentation today, though, will focus on PET, since that's the most advanced recycling market for thermoforms. But the learnings that we gain from further advancing PET recycling can be used for future efforts with other materials. So let's dive right in. We believe strongly that true circularity could not be achieved without including thermoforms. It is our mission to create circular solutions for thermoforms, keep them out of landfills, keep them out of our environment. So my presentation today is going to focus on the challenges and opportunities associated with that mission. We're going to talk about why the packaging community should care and what you can do to help lead the way. First, a little bit about thermoforming for those of you in the room that may be unfamiliar. The process starts on the left-hand side of the screen with the roll of plastic extruded roll stock shown in orange. That roll stock is fed into the machine where it is heated in an oven to a pliable state. From there, it goes to a forming station where it is molded into its design shape. Parts are still contained in the sheet at this point, where they are transferred to a trim station. They're trimmed from the sheet using a die. An example of a completed product can be shown in this image. Now, it's important to note before we move on, the waste from this process, shown in orange, is captured, ground up, and reused in future runs. So we aim for 0 waste in our process. So let's talk about why we should care about thermoform circularity as packaging professionals. So first of all, you're going to notice quotes like this across this presentation. And these were captured in listening sessions we conducted last year with brands and retailers and other key stakeholders leading the way to a more sustainable future in packaging. I'm not going to read them all, but I do want to read this one for you since it's probably my favorite and highlights why I'm here today. So sustainability is too broad of a term. The focus is on circularity, and keeping packaging out of landfills. That's why we're all here. First, benefits of thermoforms. So thermoforms have immense utility across a wide variety of applications. They play a critical role in our everyday lives, everything from preserving the food that we serve our families at night to protecting the medical devices that we trust to save lives. Given their lightweight nature and relatively low energy to produce and transport, plastic packaging actually has lower inherent greenhouse gas emissions per package than many alternatives. Also, given its ability to customize into a variety of shapes and sizes, it is a fantastic way to convey brand equity. However, we have to do a better job of creating more circular solutions for thermoforms so that we can keep them out of landfills and keep them out of our environment. I mentioned earlier how we spent 2021 talking to key stakeholders leading the way to a more sustainable future for packaging. Well, the results of that study can be seen here in this chart. So basically, in descending order from top to bottom, show the top priorities that brands, retailers, and other key stakeholders are working on in regard to sustainable packaging. It's no surprise that the majority of these activities relate to shifting to a circular economy. In fact, 80% of the organizations we connected with listed maximizing PCR in packaging as a priority their companies are working on, and 50% of them listed it as a top priority. Top priorities are shown in orange, and in dark blue is what they're working towards. I would also like to point out, and Paul touched on this earlier today in his presentation, the focus on minimizing food waste, given the critical role that packaging plays with that. So why is that important, you may ask? Well, food waste, about 1/3 of the food that we produce goes to waste. And that accounts for about 8% of global annual greenhouse gas emissions. So yes, we need more circular outcomes. There's no doubt about that. But we need to make sure that we're still minimizing food waste and not having an impact in a negative direction on greenhouse gas emissions. Demand for PCR is skyrocketing. That's reflected in this chart, courtesy of NAPCOR. So what you see here on the screen is PCR targets shown in dark blue from some of the leading consumer brand products in the company. So the targets are shown in dark blue, current levels are shown in light blue, and overall volume is shown in orange with the scale on the right-hand side of the screen. You can see these targets are pretty aggressive. You will notice that there is a gap between these targets and actual current levels that needs to close by 2025 for these commitments to be met. Please don't take this as criticism. I commend the companies that have made these commitments for doing so, and I know they are working diligently to achieve them. This is a reflection of the current state of the market, the fact that investments are needed on the supply side to help service this demand. So now you might be wondering, what are the benefits of adding PCR PET material to packaging? Well, adding it to packaging provides the recycling organizations the economic incentives that they need to operate. It also makes sure that material is being taken from landfills and recirculated in our economy. Economic benefits aside, adding PCR to packaging significantly reduces the carbon footprint and reduces our reliance on virgin materials. Also, brands are finding that adding PCR material to packaging can enhance their brand equity, especially with sustainability-minded consumers. So simply put, we should be adding as much PCR to packaging as we possibly can. Competition for PCR is stiff. So let's talk a little bit about end markets. In addition to packaging end markets like bottles and containers, fibers and strapping also consume a significant amount of PCR PET. In fact, historically, those markets have consumed the lion's share of PCR PET material. Those industries are under similar pressures that we're under in packaging to increase the amount of PCR in their products. So bottom line is PCR competition is stiff amongst several industries, not just packaging. Some positive trends I would like to point out before we move on. So according to NAPCOR, for the first time ever in 2020, packaging surpassed fibers as the largest consumer of PCR material. Additionally, it's estimated that thermoforms in California, or thermoforms are the largest consumer of PCR PET material captured in California's container redemption system. Those are all good things we hope to see continue. Kind of a complex chart, but I'm going to unpack this for you. This chart shows the national recycle rate that would be needed for beverage containers in order to achieve specific PCR content target amounts. So on the horizontal axis, you see those PCR content target amounts, and on the vertical axis on the left, you see the national recycling rate that would be required. So if you think back and recall to a few slides ago, those PCR content targets of 25% would require a national recycling rate of nearly 45%, whereas today we are close to 27%, and that's reflected in the dotted line. So there's a pretty sizable gap there from 27% to 45%, or 25% PCR to be added to all beverage containers. It should also be noted in the light blue line, that's the amount of investment that would be needed in reclamation capacity in order to get to those content targets. So to get to 25% PCR in all beverage containers, we would need nearly $1 billion of investment in reclamation capacity. That does not include investments needed in collection and sorting. So the takeaway here is there's just not enough PCR from bottles to service demand. And thermoforms are a relatively untapped source for PCR. PET thermoforms are recycled today. when designed for recyclability guidelines are applied. However, recovery rates for thermoforms significantly lag those of beverage containers. So in 2020, nearly 134 million pounds of PET thermoforms were recovered. That sounds like a lot of material, and it is, but it equates to a recovery rate of 7.3%, significantly lagging 26.6% for bottles. That means we have close to 1.7 billion pounds of thermoforms available for recovery. That's the opportunity in front of us, and that's why we're here today. How are thermoforms recycled today? Well, they're typically included in low percentages in curbside bottle bales. Material recovery facilities, or MRFs, typically cap the level of thermoforms in bottle bales at 10 to 20%, kind of based on agreements that they have with their customers. Unfortunately, many of those agreements don't allow thermoforms at any level. There is a good news though. MRFs on the West Coast are starting to sort out thermoform only bales, known as thermoform clean wash flake, or TCFW. This market is just emerging, but it is evidence that recovered thermoforms can have value. I'd be remiss if I did not mention the impact of legislation before we move on. So state and federal policymakers are enacting policies aimed directly at plastic packaging at unprecedented levels. Now, intelligently crafted, science-driven policies that break barriers can enable change. However, we cannot rely on government intervention alone to solve our problems. We need to lead the way by working together as an industry to create these circular solutions so that we can continue to reap the many benefits that these applications offer. All right, so now that we discussed the opportunity, let's move on to challenges. So why is this difficult? I think we need to frame the challenges around the definition of recycling and the practice of recycling. And there's kind of four pillars there. There's access or collection, there's sortation, there's reprocessing, and then there's end markets. And this kind of follows the Association of Plastics Recyclers definition of recyclability, which reflects FTC green guides. So according to that definition, 60% of us must have access to collection systems that accept the item. The item must be sortable with like items into market-ready bales. It must be reprocessed cost-effectively in a typical recycling process. And perhaps most importantly, it has to have market value at the end of the day. Someone has to want to purchase it. Let's step through these one by one. So according to a declaration in 2020 from the Sustainable Packaging Coalition, access rates for thermoforms fell below the 60% threshold to be widely recyclable. It's primarily due to the impact on municipal recycling programs of waste import bans, namely China's Green Sword Initiative. So despite public perceptions, these recycling programs are very costly to operate. What this means is that PET is designated as a check locally in the How to Recycle program, which basically is a qualified recyclability claim. Sortation. So it should be no surprise that America's recycling infrastructure needs modernization. And that's not a criticism of MRFs. As packaging creators and converters, we've placed significant burdens on them given the rapid evolution of packaging shapes and structures over the years. So there's no doubt that investments are needed in order to capture thermoforms at a higher rate than they're captured today. So recyclers that reprocess thermoforms have some unique challenges. So thermoforms tend to have a lower intrinsic viscosity than bottles, and that intrinsic viscosity directly relates to its mechanical properties. So what that means is that if you're going to collect thermoforms and eventually use them in packaging applications such as bottling, where FDA type regulations are required, that has to go through additional processing steps to boost the IV. Some other challenges that recyclers face is contamination from lookalike packages like PVC, PLA. It's also notable that you will see color variation and inclusions and specs and things like that. Also, it's known that labels, inks, and attachments can have significant impacts on the recyclers. That said, thermoform to thermoform recycling has been proven feasible, both in pilot scale and commercially. And the pictures on the screen, I'll share a little bit more detail about that, are from a study that NAPCOR conducted a few years back, studying the feasibility of thermoform to thermoform recycling. This basically shows the contaminants filtered out of a PCR material from thermoform bales from 3 different recyclers. So each screen is from material from a different recycler. The recyclers use the same bales. So the variation that we see is reflective of the variation of the capabilities of those recyclers. It underscores the importance of understanding the various capabilities that recyclers have so that we can tailor unique solutions to break through those barriers. So a robust end market is needed to inspire more collection of thermoforms. But there are some major headwinds, and notably among them, so virgin plastic is relatively inexpensive to produce, and typically there is a cost premium associated with PCR PET for packaging applications. Also, the cost to landfill waste is relatively inexpensive compared to the cost of going through a recycling process. So these are major headwinds, not just for recovering more thermoforms, but for PCR adoption across the board. What's the upshot here? So thermoforms are at risk of deselection by policymakers and consumers if we don't focus more on recovery. Additional recovery is needed to ensure long-term viability. Now, the good news is advancements in technology, industry collaboration, and brand commitments are helping to accelerate progress despite the headwinds that we're facing today. I'm optimistic that recovery of thermoforms are going to continue to grow. Let me share with you a few reasons why I'm optimistic. Collaborations such as the Collaborative PET Thermoforming Project by Resource Recycling Systems and the PET Recycling Coalition from the Recycling Partnership are some of the largest collaborations to date of brands, recyclers, resin producers, converters, and trade organizations focused on the recovery of thermoforms. So RRS is estimating that millions of additional pounds of thermoforms and bottles can be diverted from landfill to recyclers through this project. And that can be shown in the orange and blue shaded areas of this chart. I'm very excited to see where this project goes and what progress is made over the coming years. Also, brand commitments. Trade organization by the name of Berry Sustainable has been advocating for increased recovery of thermoforms. Also, Driscoll's is an example of a national brand leading the way to thermoform circularity. They've pledged to use PCR recovered strictly from thermoforms in their clamshell packaging. And the way they've built a supply chain for this material through collaboration is a best practice I think we can all learn from. Further demonstrates also that thermoforms, recovered thermoforms do have value. Another reason for optimism is the advancement of technology, in particular in the sortation equipment. So things like NIR sorters, artificial intelligence, things like that make it more economical and more efficient to capture thermoforms and sort thermoforms at the MRF level. Now these technologies do require a significant amount of capital, and that underscores the need for a stable market to provide the justification for the return on that capital so that those investments can be made. I'd also like to note that the processing technology is also advanced in order to keep up with demand. Some examples of that include twin screw extrusion and property boosting equipment that also improve the purity and the quality of the PCR material. And that's absolutely critical to be able to get it back into thermoforms and bottles. Lastly, molecular recycling, also known as advanced recycling, provides the industry with a potential long-term solution to bridge the supply and demand gap. This is really, it's a consortium of technologies. And essentially what they do is they turn back the clock on waste by converting the waste material into its molecular building blocks, or breaking it down into its molecular building blocks, where it can be reassembled into virgin-like polymers. This could be ideal for hard to recycle materials like carpeting or thermoforms made from multiple layers. It will take time to scale this technology, but the investments we are seeing from brands, equity firms, and resin suppliers certainly is reason for optimism. So look, I'm going to be candid now. As a packaging professional looking to create more circular solutions for packaging, there's a lot outside of our control, and it can be frustrating at times. So I'm going to focus on the positives. I'm going to wrap this presentation up by talking about some recommendations you can make, some actions you can take using readily available technology and well-established best practices. Pledge to use PCR in your packaging. Specify PCR from thermoforms if it is appropriate to your business model. These commitments, speaking as a packaging converter, these commitments are so critical. It helps us gauge the needs of our customers and feeds into our decision-making processes like capital planning. And when you do this, it's important to be transparent and hold yourself accountable, and that will continue to build trust. Designing recyclable packaging is hard. And let's not forget that the primary job of a package is to preserve and protect its contents. The APR Design Guide is an excellent resource that's available to all for free on their website. And it provides basically preferable attributes that you can use for designing for recyclability, as well as detrimental features you can avoid when designing packaging. Make sure that your package designers are familiar with these principles, they're fluent with them. Most importantly, ingrain them into your packaging development process. So adding PCR to a package can require compromise. It's important to gauge with your internal stakeholders to determine what is truly critical to quality and brand equity so that specifications can be flexible enough to include PCR. Also, PCR can tend to increase the cost of an item given the differential between PCR and virgin. Work with your suppliers to identify ways that cost can potentially be removed from the item, like down gauging, to help neutralize the cost of adding PCR. So consumers want to purchase from brands that they see as sustainable. Do not be afraid to share your sustainability story to help quench that demand. This is going to be even more important as the purchasing power of younger generations continue to grow. I don't have a picture of this, but Hellman's Mayo is an excellent example of this. You can go to their website and see in large letters, we are committed to PCR. So consumers overwhelmingly express a desire to recycle, but confusion along with inequitable access to recycling systems is a primary reason they do not. The How to Recycle label by the SPC was developed to provide explicit directions on how to recycle an item. Deploy the How to Recycle label on your packaging to clear up confusion, and most importantly, build trust and confidence in our recycling systems with consumers. Get involved locally. So recycling is a very decentralized process. Capabilities can vary greatly from one community to another. Visit a local MRF, visit a local recycler, try to wrap your arms around how your package flows through their process. Get a sense for what their gaps and pain points are, and try to understand what some of the true end-of-life outcomes your package may be likely to experience. Take all those learnings back to internal stakeholders for consideration. Engage up and down the value chain. So connect with stakeholders, whether they're suppliers, challenge them, let them know what your needs are, where you need help, where your gaps are, and also try to learn what their gaps and limitations are to see where you can help. So shifting to a circular economy, improving the circularity of packaging, it's gonna require an unprecedented level of collaboration. I'd urge you to join an organization that is focused on improving the circularity of packaging. And just several examples of these excellent organizations are on this slide. We need to work together as an industry if we're going to make the progress towards circularity that is rightfully expected of us. All right, with that, if you remember 3 things from this presentation, PCR is in high demand, there's not enough of it to go around, and recovering more thermoforms can help bridge that gap. And quick plug before we move on, if you found this interesting, you can visit our website, download our circularity report for more information on this topic and others. That.
Great. Thanks very much, Zach. And picking up on the consumer point, our next panel will be talking just about